Supreetha. Welcome to my math class. In the previous lecture on Laplace transform, what did we study? We studied the basic definition of Laplace transform. We saw some formulas, basic formulas on Laplace transform. We solved some direct problems on them. Yes, we used some trigonometric formulas to simplify the question. Yes, and then we applied the Laplace transform. And then we studied how to find the Laplace of functions, say in the form e power at into f of t. Yes, and the property that we use to solve this is called as shifting property. Okay, this is called as shifting property. And secondly, for finding Laplace of something of the form t power n into f of t, we use the second property, which is called as derivative property. Yes, okay. So suppose our question is something like find the Laplace transform of a function divided by t. How do you solve this? As usual, the first step is identify f of t, okay, and find the Laplace of it. You will get f bar of s, okay. And the second step is, yes, that is Laplace of f of t divided by t is integrate whatever you have f bar of s from s to infinity. Okay, so let me take a problem on this. Say, first one is find the Laplace transform of 1 minus e power minus at divided by t. Okay, what is our f of t here? F of t is equal to 1 minus e power minus at. What is Laplace of f of t? Laplace of f of t is Laplace of 1 minus e power minus at. Okay. What else do? We give Laplace to each term. Okay, Laplace of e power minus at. What is the formula for Laplace of 1? It is 1 divided by s. What is the formula for Laplace of e power minus at? It is 1 divided by s plus a. Okay. Now, this is our f bar of s. What are they saying? What is the formula? The second step is find the Laplace of f of t divided by t. That is, Laplace of f of t divided by t is integrate from s to infinity. What do you integrate? 1 by s minus 1 by s plus a with respect to ds. Okay. Now, let me give the integration sign to each term. 1 divided by s ds minus integral s to infinity 1 divided by s plus a ds. What is the integration of 1 divided by s? It is log s. Minus, what is integration of 1 divided by s plus a? It is log of s plus a. What are the limits? The limits are from s to infinity. Okay. Now we have, yes, we have log s minus a. What is log a? Okay. What is log a minus log b formula? Log a minus log b is log a divided by b. Okay, let me do that over here. In place of a, I have s. So I'll write it as log a divided by b. In place of b, I have s plus a. So the limits are still s to infinity. Okay, what is the upper limit? Upper limit is infinity, right? So if I substitute infinity, I'll get infinity by infinity minus log s divided by s plus a. Lower limit is s itself. Okay, we integrated with respect to s. Yes, so wherever we have s, we replace it with. We integrated with respect to s. So we apply limits, that is s to infinity to s. Okay, that is wherever you have s, replace it with infinity for upper limit. And infinity for the upper limit, and wherever you have s, replace it with s for the lower limit. Okay, this is all basics of integration. Now, infinity by infinity is called as what? Indeterminate form. Yes, infinity by infinity is called as indeterminate. How do you solve this? Okay, let me go back to the previous step. Let me take the or write the question as it is, log of s divided by s plus a. So I'll try to make some little bit of changes to this. Okay, before applying infinity, I'll get s divided by, I'll get s, okay, s plus a. Let me multiply and divide s here. S and s gets cancelled. Okay, now 1 divided by, I'll get 1 plus a by s, correct? Why? If I divide s with s plus a divided by s, s and s gets cancelled. Okay, minus log s divided by s plus a minus log s divided by s plus a. Even here I have minus log s divided by s plus a. Now for the first term, if I apply limits now, okay, that is s is equal to infinity. If I apply the limits, I would get log 1 divided by 1 plus 0, that is log 1. What is log 1 value? Log 1 value is 0, right? So we'll get it as, yes, we'll get 0 minus log s divided by s plus a. So this is something like minus 1 into log s divided by s plus a. Now, what is the formula of a log b? Can we write a log b as log b power a? So now what will we get? We'll get log s divided by s plus a whole power minus 1, or if you flip it, that is if you want a positive power, I can write it as s plus a divided by s. What is this? This is the Laplace of 1 minus e power minus at divided by t. Okay. Now moving on to our next question, that is, so yes, our question is find the Laplace transform of 2 sin t divided by sin 5t. Sorry, Laplace of 2 sin t sin 5t divided by t. So what is the first step? Find the Laplace of, okay, find the Laplace of 2 sin t sin 5t. Why? This is the f of t, right? So what should I do? Let me take 2 common. Write Laplace of sin t. Yes, sin 5t. Now what is sin A sin B formula? Sin A sin B formula is half, okay, cos of A minus B plus cos A plus B. Okay, sorry, this is a negative, right? Cos A minus B minus cos A plus B. Okay, now what should I do? Let me apply this formula to our given question, that is 2 Laplace of, I'll replace sin t sin 5t with half cos t minus 4t is minus 4t minus cos 6t. Now what is cos of minus theta? Cos of minus theta is cos theta. Yes. Now this 2 and this 2 gets cancelled. Apply Laplace to each term. So this would be plus cos 4t. On applying Laplace transform for each term, I would get s divided by s square plus 16 minus s divided by s square plus 36. Okay, what is this? This is f bar of s. Now what should I do? What is the second step? Find the, that is Laplace of f of t divided by t is equal to integrate from s to infinity f bar of s ds. Okay, what is our f bar of s? F bar of s is s divided by s square plus 16 minus s divided by s square plus 36. This is our ds integration ds s to infinity s to infinity. Okay, now let me take the integration part and solve it first. Okay, what do we have? Integration of s divided by s square plus 16 ds. How do you solve this? Let me use something called as substitution method. What is the substitution method? I'll take s square plus 16 as say t. Now after differentiating I would get 2s ds is equal to dt. Okay, now s ds is equal to dt divided by 2. Let me substitute. What is s into ds? It is dt divided by 2 and 1 divided by t. Half is a constant, I'll take it out. Integration of 1 by t dt is what? Log t. Okay, if I substitute in place of t, I'll substitute back whatever the substitution that we took. That is s square plus 16. Okay, now I can use this as a formula, right? S divided by s square plus any constant is equal to 1 by half of log s square plus that constant. Okay, so let me do that. Let me substitute from equation 1. Okay, equation 1 would become, what would it become? Half log of s square plus 16 minus half log, yes, s square plus 36. Yes, we have 36 over here as you can see. Okay, now I'll take out half common. Okay, half is common. Log of a minus log b, I'll directly write it as log a by b. Okay, now what is our next step? We should apply the limits s to infinity, right? Even here we had to apply s to infinity. Yes, let me do the upper limit now. Upper limit is infinity, right? So that would be log infinity by infinity. So what should I do? Let me take the question, that is s square plus 16 divided by s square plus 36. What will I do in the numerator? I'll multiply and divide it with s square. Okay, what will I have then? I'll divide s square with each term. I'll get 1 plus 16 divided by s square divided by the same thing, multiply and divide with s square. I'll get 36 divided by s square. S square and s square gets cancelled. Now if I apply the limit, that is infinity, I would get log 1 plus 0 divided by 1 plus 0, which is log 1. What is the value of log 1? Log 1 value is 0. So upper limit would be 0. Yes, let me name that as equation 2. Okay, from equation 2 we have, yes, what do we have? We have a half. Upper limit would be 0. Lower limit would be as it is, that is log s square plus 16 divided by s square plus 36. Same like in the previous problem. I have negative 1 into, so I'll write it as, if I have a log b, I can write it as log b power a. So what I'll do, I'll write it as log, okay, s square plus 16 divided by s square plus 36 to the power minus 1. So this would become half log s square plus 36 divided by s square plus 16. Okay, again we have a log b, so I can write it as log of log of the bracket to the power half. Instead of writing to the power half, I'll put a square root. Okay, so this is our required Laplace transform. Okay, so yes, what all did we study? Okay, let me just revise a little bit. Yes, so we studied something called as, we studied three properties. Agree? What were the three properties? Now, suppose I have, say, if they ask me, find the Laplace transform of a function e power at into f of t. Another one is t power n into f of t. The other one is f of t divided by t. Okay, here the first step is identify f of t, find the Laplace of it. Yes, the same thing with all the other three. Yes, the first step is same for all the other three too. Let me just write it down. Okay. Yes. So what is the second step for e power at f of t? The second step was, yes, what we had to do? We used to get here what? F of s, right? Not t. Laplace of f of t is f of s. F or f bar of s. It all means the same. Okay, we used to get f bar of s. What was the second step here? Whatever f bar of s I got, okay, whatever this f bar of s was, I had to replace it with s minus a. What was the second step over here? That is Laplace of t power n f of t. This is equal to minus 1 to the power n dn divided by ds to the power n into f bar of s. Okay, what was the third property? What should we do in the third property? What is the second rule in the, or the second step in the third property? That is, whatever you found, that is f bar of s, Laplace of f of t divided by t is equal to what? Integrate from s to infinity that f bar of s, whatever you got with respect to s. Okay, so these are the three important properties that we use to find Laplace transform. So what did we study in today's class? We studied how to find, yes, the Laplace transform of the functions which is in the form of f of t divided by t. Yes, as I told you, first identify f of t, find the Laplace of it, and then integrate it. Okay? So yes, that is it for today's lecture. Thank you.